Hello, good afternoon to all of you. I hope all of you are doing well. So in today's class, we're going to learn about coding phase. So coding is an explicit phase in case of software lifecycle that aims at translating the design into set of executable code, adhering to certain coding guidelines and coding standards. In order to define coding phase in a very simple term, it's a phase that is capable of translating the design into executable code. Now, during coding phase, what we normally perform is we normally perform translation of design into executable and unit testing of the executable that has been created. Now, there might be a question that may be raised that what is unit testing, right? And why do we need it? What is integration testing? Why do we need it? And what is system testing and why do we need it? Now, as we have already specified that unit testing is the testing of module in isolation, so it basically refers to a situation where what we tend to do is we tend to determine the ability of the module to deliver the expected result, or a mechanism for determining the integrity of the module that has been implemented or translated. So unit testing is a mechanism of determining the ability of a module to deliver the expected results as specified in the specification document. Now, in order to unit test a module, what we need to do is we need to create a test environment. Now, in a test environment, what we have is we have a driver, we have a stub, and we have the module under test. So the driver invokes the module in the test, the module in the test invokes the stub, right? And the module and the driver is also responsible for providing information about any non-local data structure that the module and the test requires in order to perform operations. So this is these are the constituent elements of the test environment. So a test environment has to have a driver that invokes the module in the test. It has to have stub that is invoked by the module in the test, and it should provide the non-local data structure has to be there, that has to be provided by the driver. So now, once the module has been unit tested, that basically means once the ability of the module has been determined to deliver the expected results, then what we need to do is we need to move on to integration testing. But before moving on to integration testing, let us try to understand why do we actually need unit testing, right? Okay, so the reason why do we need unit testing is, first thing is to determine the ability of the module to adhere to the specification. Second one is to restrict the size of the restrict the size within which the errors, if committed, can be determined, right? Because just see, if you are trying to determine an error within a module, right, the size may be considerably less compared to that of situation when we are trying to determine the error in a collection of module, right? Okay, so localization of error becomes very easy whenever you go for unit testing, right, rather than trying to localize error in a set of modules. So that basically implies that debugging in case of you debugging becomes very easy in a situation where the search space for the error is minimized. So that is the objective of unit testing. So one of the objective of unit testing is to check for the ability of the module to deliver the expected result, and the second one is to restrict the size of the size of the search space for the error, so that we can bring identify the point of origination, and we can bring about a change with relative ease. Now, once unit testing is over, what we need to do is we need to carry out integration testing. Now, integration testing is the testing of the ability of the modules to interact with each other, right? Or determining the ability of the modules to interact with each other. So once we have implemented the system in terms of modules that are individually tested, what we need to do is we need to integrate the module and integrate the modules and then determine the ability of the modules to deliver the expected result. Because what we want is we want the modules to interact with each other and realize the behavior of the system, right? Individually, the modules may be capable of delivering the expected results, but it may so happen in situation they may not be capable of integrating with each other. So that is the objective of integration testing. Very objective of integration testing is to determine the ability of the modules to interact with each other. So that's the reason why it's also called as interface testing, right? So there are different approaches of interface testing or integration testing. These are called as Big Bang approach, top-down approach, bottom-up approach, and mixed mode approach. Now, Big Bang approach basically tries to integrate the entire set of modules in a single step of integration, right? The advantage is that if the modules are capable of completely integrating with each other, then this should be the best approach for integration. But in situation if there is an error encountered, then the search space for the error will be the entire system. So in order to overcome the disadvantage of Big Bang approach, top-down integration and bottom-up integration was proposed, where in case of top-down approach, we tend to prioritize the modules, and at different levels of integration we tend to integrate the modules with different priority. And in case of bottom-up approach, what we tend to do is we tend to group up modules with similar behavior into groups, and then the groups are integrated to form subsystems, and subsystems are integrated to form systems. So depending upon your requirement, what you can do is you can pursue bottom-up integration or top-down integration. Now the next integration strategy that we have is called as mixed mode, where at different levels of integration either you can pursue top-down approach or bottom-up approach based on the requirement of the system, right? So for now, just remember what is integration testing, or what are different types of integration testing, and what is unit testing, because we are going to discuss each of this in detail in the next chapter, right? So now let us talk about the next type of testing, that is called as system testing. So system testing is the testing of the system in order to determine the capability of the system to deliver the expected results. So we have alpha, beta, and gamma testing, right? Okay, or alpha, beta, and acceptance testing. So alpha testing is a testing that is done by the members of the development team. Beta testing is a testing that's done by the members of the friendly organization, and acceptance testing is a testing that's done by the actual customer to decide upon whether or not to accept the software system. Again, I'll repeat it. Alpha testing is carried out by the members of the development team. Beta testing is carried out by the members of the friendly organization, and acceptance testing is a testing that's carried out by by the members of the client organization to decide upon whether or not to accept the software system. So these are the significances of these three testing mechanisms. We have unit testing, we have integration testing, and we have system testing. So we'll be learning about it in greater detail in the testing chapter. But for now, just remember that these are the three testing mechanisms that we have. So till now, what we have learned what is coding, or we have learned when coding starts. We have learned about what are the activities that are performed during coding phase. We have learned about the significance of unit testing. We have learned about the integration testing. We have learned about the significance of integration testing and types of integration testing, and we have learned about system testing, and we have learned about different types of system testing. Now, for your understanding, the reference for unit testing, integration testing, and system testing will be the SRS document, because SRS document is a document that is accepted upon by the customer and the developer. So this document will be used as a basis for testing the software system. Now let us try to move on with coding, and let's try to focus on coding, right? So coding is a phase, as I've said, is a phase that is initiated after design phase, that tries to translate all the models that are identified in the design model into executable code, right? Using design specific programming platform. But whenever we are trying to translate the design into executable code, what we need to do is we need to ensure that the coding standards and coding guidelines are being followed. So at the end of design phase, what we have is we have module structure of the system, right? Again, where modules are organized, and with each and every module we have module specification that tries to emphasize upon the algorithm and the data structure that is to be pursued for realizing a particular module, right? So the objective of coding phase is to transform design into code and to unit test that particular code. Now let us talk about coding standards. So why do we need to follow coding standards? So a good software development organization requires the programmer to follow certain coding style. Now these coding styles are called as coding standards, right? Okay. So every organization have with them associated set of coding style. So these are called as coding standards. So we have organization specific coding standards. So organization needs the programmer to follow it, because coding standards helps in elevating the uniformity of representation, thus facilitating readability, understandability, acceptability, and maintainability. Right. Okay. So again, I'll repeat it. So adherence to coding standard elevates elevates the uniformity of representation, which further facilitates readability, understandability, acceptability, and maintainability. Right. Okay. So just see, many software or development organization formulates their own coding standards, and they enforce the coding standards to be followed upon religiously or and rigorously, because coding standard basically helps in elevating the uniformity of representation, which helps in elevating understandability, readability, understandability, acceptability, and maintainability. So just see, in order to ensure that the software system is not only understandable but also maintainable, what we need is we need the coding standards to be adhered to. Now, a coding standard, these are nothing but the coding styles that may be related to naming of variables, naming of identifiers, right? Again, naming of functions, the way how the code is to be laid, the way how the programming constructs are to be placed, the way how the formatting is to be done, right? The decision on the number of instructions that may be placed in a particular function. So these are all decided upon in case of coding standards. Now let us try to just go through what is code inspection and code walkthrough. Now, code inspection and code walkthrough, these are processes that are initiated before the execution of testing phase. So, before the initiation of the testing phase, what we have is we have a phase that is we have a process that is called as code walkthrough and code inspection, that is done after coding phase, in order to ensure that there is a compliance between the function specification and the code, and the coding standards are followed, right? Okay, so that is the objective of coding code inspection and code walkthrough. So these are processes that are initiated after coding phase and before the initiation of testing phase, to ensure that there is a compliance in terms of coding standards and there is a compliance in terms of conceptual integrity of the function, right? So after a module has been coded, code inspection and code walkthrough are carried out just to ensure that the coding standards are followed. It helps in detecting common types of errors that may be there, all right, before testing. Now, why do we need to execute code inspection and code walkthroughs? Because if we are capable of resolving the issues related to code before the onset of the testing phase, then the total amount of cost that may be incurred may be considerably less. So in order to facilitate that, what we need to have is we need to have code inspection and code walkthrough. So it helps in detecting errors, right? It helps in detecting errors with relative amount of ease, and what we can do is we can bring about correction to that, right? So much higher effort is needed if the errors were detected during integration testing or system testing or unit testing, right? So that is the reason why what we need to have is we need to have code inspection and code walkthrough. So we'll be discussing about code inspection and code walkthrough in the upcoming class, right? Now, some of the representable coding standards. So the rules for limiting the use of global variables. So we need to know about what all variables are to be kept as global variables, and what all variables are to be kept as local variables. Naming conventions, so naming convention for the variables. So from local variables are to be written in lowercase, global variables are to be written in title case, and constants are to be written in uppercase. So, right, so this is one of the representable coding standard, right? So content of the module header has to be decided upon. So with every module we need to have a module header, where module header has information like description of the module, the date on which the module was created, author's name, modification history, description of the various parameters, right? Synopsis, right? Global variables that are accessed and modified. So this should be the content of the model header, right? Now, error return conventions, the way how the errors are being handled and exceptions are being handled, and how tagging of error is done in order to make someone understand that what kind of error has been committed. So by creating a very simplified representation of the code, what we can do is we can make the code understandable. Now, some people have the habit of writing clever constructs for the program so that others cannot understand. So such kind of approach should be avoided, right? So we need to avoid obscure side effect in situation where the way how the local variables, global variables are being manipulated are not tracked. Then it may be difficult for one to monitor the progression or the way how the function would behave. So there has to be a proper mechanism defined for the way how the variables are accessed, okay, and how the values are modified. So what we should not do is we should not use same identifiers for multiple purpose, right? The code should be well documented. So when and wherever we can associate comments, what we need to do is we need to associate comments for elevating the understanding of the code. The length of the code, right, should be controlled, right? So it is said that in order to implement a particular function, maximum 10 lines of code should be used, right? So in situation where the function becomes complex, we need to decompose the function into sub functions, right? So lengthy functions are very difficult to understand, right? And it may be very difficult to eventually it may be very difficult to manage as well. So we need to avoid any structure that leads the program to be unstructured. So we've learned that for program can be called as a structured program if it follows sequence selection and iteration. So if any of these are violated, then program becomes unstructured program. So that has to be avoided. So in today's class, what we have learned about is we have learned about what is coding. We have learned about what is unit testing and why do we need it. We've learned about what is integration testing and why do we need it. We learned about system testing and why do we need it. We learned about what would be the basis for system testing, integration testing, and unit testing. Then we focused on coding and importance of coding, right? Again, we've learned about objective of coding. We've learned about the importance of coding standards, right? Again, we learned about coding guidelines. We learned about code inspection and code walkthrough. Why do we need to have code inspection and code walkthrough before the onset of testing phase? And we learned about some of the coding standards, representable coding standards, right? And in the next class, what we're going to learn about is we're going to learn about in detail what is code inspection and code walkthrough, right? And then we are going to continue with the chapter. So thank you very much.